In this video, we shall be discussing three concepts of straight line. Number one, angle between two lines. Number two, distance of a point from a line. And number three, distance between two parallel lines. Hello friends, you are watching channel Number Collage. This channel features concept videos on mathematics which you would love to watch. We are going to discuss angle between two lines. Let us draw x-axis, y-axis, origin. Suppose inclination of line L at point C on the x-axis be theta 1, so that slope of line L will be m1 equals tan theta 1. Another line M cuts line L in point A and its inclination at point B on the x-axis is theta 2, so that slope of line M2 will be tan theta 2. We are going to find a formula to find angle between line L and M, which is this theta. Now by exterior angle property, we know that theta 1, which is the exterior angle of triangle ABC, equals theta 2 plus theta. That gives us theta equals theta 1 minus theta 2. Now we will take tan on both sides of this and write tan of theta equals tan of theta 1 minus theta 2. By trigonometric formula, we have tan theta 1 minus theta 2 equals tan theta 1 minus tan theta 2 upon 1 plus tan theta 1 into tan theta 2. So we will substitute the values. Tan theta 1 is m1 slope of line M minus tan theta 2 is m2 slope of line M upon 1 plus tan theta 1 is m1 into tan theta 2 is m2. So we write theta equals tan inverse of m1 minus m2 upon 1 plus m1 m2. If we want acute angle between the two lines, then we have to take positive value of m1 minus m2 upon 1 plus m1 m2. So therefore, for acute angle theta, we write tan inverse of mod of m1 minus m2 upon 1 plus m1 m2. So theta equals tan inverse of mod m1 minus m2 upon 1 plus m1 m2 gives us the formula to find acute angle between the two lines whose slopes are known. How to find distance of a point from a line? X-axis, y-axis, origin. Let's draw a line whose general equation is ax plus by plus c equals 0. We have to find the distance of this point P whose coordinates are x1, y1 from this line, which is ax plus by plus c equals 0. That is, we have to find the perpendicular distance PQ. Let us denote this distance as d. The point of intersection of the line with the x-axis be A, whose y coordinate is 0. In order to find its x coordinate, we will substitute y equals 0 in this equation, so that we get Vy equals 0. Therefore x will be minus c upon a. So we write the x coordinate of a as minus c upon a. Similarly, the line intersects the y-axis in point B, whose x coordinate will be 0. In order to find its y coordinate, we will substitute this x equals 0, so that ax becomes 0 and y becomes minus c upon b. So we write the y coordinate of b as minus c upon b. We will draw segment BP and segment PA to complete the triangle PBA. So area triangle PBA will be half into base AB into height PQ, which gives us PQ, which is the distance of point P from the line, which is D, equals 2 times area triangle PBA by AB. We will find area triangle PBA and length AB separately. Area triangle PBA will be half times x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Now we will substitute the various values and write 2 times area triangle PBA equals x1 times minus c upon b minus 0 plus x2 is 0 times y3 is 0 minus y1 plus x3 is minus c upon a times y1. y2 is minus c upon b, but it will be plus c upon b. So this 2 times area triangle PBA will be equal to x1 into minus c upon b, that will be minus c upon b x1. 0 into 0 minus y1 will be 0. Next, minus c upon a into y1 will be minus c upon a y1, and minus c upon a into plus c upon b will be minus c square upon ab. We will take LCM of b, a and ab and write here. So ab upon this b will be a. So this will be minus ac x1. ab upon a will be b. So that will be minus bc y1 minus ab upon ab will be 1. So this will be directly minus c square. Since area will be a positive quantity, we will write the further simplification in modulus sign. So taking c common from the numerator, we will write mod c by this ab times mod a x1 plus b y1 plus c. So this will be twice area triangle PBA. Next, we will find distance AB by distance formula. We write AB equals under root 0 plus C upon A whole square plus minus C upon B minus 0 whole square, which will be under root C square upon A square plus c square upon b square. AB will be under root c square b square plus c square a square by a square b square, which will be under root, taking c square common, a square plus b square upon a square b square, which we can write as, since we have to write only the positive values, so we write square root of c square is c and square root of a square b square will be ab. We write this in mod because it's going to be positive, multiplied by under root a squared plus b squared. So ab finally will be mod c upon ab times under root a squared plus b squared. Now we will substitute the values of 2 times area triangle PBA, which is this, and the value of AB, which is this, to find PQ or D. So we write D equals mod C upon AB times mod AX1 plus BY1 plus C upon AB is this mod C upon AB times under root A squared plus B squared. Mod C upon AB gets cancelled and we get the value of this D that is the distance of point P x1 y1 from this line a x plus by plus c equals 0 as PQ, or D equals mod a x1 plus b y1 plus c upon under root a squared plus b squared. This is the formula for finding the distance of a point P x1 y1 from the line ax plus by plus c equals 0. We will discuss how to find distance between two parallel lines. Suppose we are given two parallel lines L and M. Let equation of line L be ax plus by plus c1 equals 0 and equation of line M be ax plus by plus c2 equals 0. We have earlier seen that in the equations of two parallel lines, the coefficients of x and coefficients of y are either equal or are proportional. The only difference between the equations of parallel lines is they have different constant terms c1 and c2. Suppose p x1 y1 be a point on the line L. We draw a perpendicular from point P on the line M. This point is Q. Since point P x1 y1 lies on the line L, whose equation is ax plus by plus c1 equals 0, the coordinates of P x1 y1 satisfy this equation. So we will substitute the values of x1 y1. So we get a x1 plus b y1 plus c1 equals 0. That gives us a x1 plus b y1 equals minus c1. Let us name this equation 1. Length PQ, that is the distance of point P x1 y1 from the line M, will be mod a x1 plus b y1 plus c2 upon square root a squared plus b squared. But ax1 plus by1 equals minus c1. So PQ will be mod minus c1 plus c2 upon square root a squared plus b squared. Therefore, finally, length PQ, which we denote by letter P, will be PQ equals P equals mod c1 minus c2 upon under root a squared plus b squared. So this formula gives the distance P between two parallel lines L and M. How to find acute angle between the lines 3x minus y plus 4 equals 0 and 2x plus y minus 3 equals 0. The first equation can be written as y equals 3x plus 4, which gives slope of this line m1 equals 3. Second equation can be written as y equals minus 2x plus 3 minus 2 is the slope m2 of this line. Let theta be the acute angle between these two lines. We have tan theta equals mod m1 minus m2 upon 1 plus m1 into m2. It will be mod 3 minus 2 upon 1 plus 3 multiplied by minus 2. It will be 3 plus 2 5 upon 1 minus 6, which will be 5 by minus 5, which will be mod minus 1, which is 1. Since tan theta equals 1, which implies that theta equals tan inverse of 1, which is 45 degrees or pi by 4 radians. Let us find acute angle between the lines 3x plus 2y equals 6 and 2x minus 3y equals 5. First line can be written as 2y equals minus 3x plus 6, y equals minus 3 by 2, x plus 6 by 2. Minus 3 by 2 will be the slope m1 of this line. The second line can be written as 3y equals 2x minus 5, y equals 2 by 3x minus 5 by 3. Here 2 by 3 is the slope m2 of this line. Now that we know the slopes of these two lines, if theta is the acute angle between these two lines, we have tan theta equals mod m1 minus m2 upon 1 plus m1 into m2. Substituting the values, minus 3 by 2 minus 2 by 3 upon 1 plus minus 3 by 2 multiplied by 2 by 3. This will be mod 3 threes are minus 9 minus 4 by 2 threes are 6 divided by 1. This 3 cancels, this 2 cancels, and minus 1 into plus 1 will be minus 1. So this will be minus 13 by 6 upon 0. Here tan theta is undefined. Therefore, theta, the acute angle, is 90 degrees or pi by 2 radians. How to find distance of point 5, 4 from the line 2x plus y plus 6 equals 0. Let this point be P. Draw a perpendicular on this line which is PQ. We have to find length PQ which is D. We have 5, 4 equals x1 y1. This 2 is A. This is B which is equal to 1, and this 6 is C. The formula to find D is given as D equals mod ax1 plus by1 plus c upon square root a squared plus b squared. By substituting the values, mod a is 2, x1 is 5, plus b is 1, y1 is 4, plus c is 6 upon square root a square is 2 square plus b square is 1 square. So it will be equals mod 10 plus 4 plus 6 by square root 2 square is 4, 4 plus 1 5, which will be 20 by root 5, 5 multiplied by 4 by root 5. This will become root 5, root 5 ones are. So distance D will be 4 root 5 units. How to find distance between two parallel straight lines whose equations are 5x minus 12y plus 1 equals 0 and 10x minus 24y minus 1 equals 0. We have to find the perpendicular distance between these two parallel lines, which is P. We know that when two lines are parallel, then the coefficients of x and the coefficients of y are either same or they are in proportion. In the second equation, we can divide throughout by 2, so which gives us 5x minus 12y minus half equals 0. So now we observe that the coefficients of x and the coefficients of y are same. The only difference is in the constant term c1 and c2. Moreover, we have a equals 5 and b equals minus 12. We have the formula to find p as p equals mod c1 minus c2 upon square root a squared plus b squared. Substituting the values, we write c1 which is 1 minus c2 which is minus half upon square root a square. A is 5, so 5 squared plus b is minus 12, so minus 12 squared. It will be mod 1 plus half upon 5 square is 25 minus 12 square is 144. It will be 3 by 2 divided by 25 plus 144 is 169 and square root of 169 is 13. So P will be 3 by 13 twos are 26. So the distance between these two parallel lines will be 3 by 26 units. We will see how to find distance between two parallel lines. 4x minus 3y minus 9 equals 0 and 4x minus 3y minus 24 equals 0. We have to find the perpendicular distance p between these two lines. We know that when the two lines are parallel, the coefficients of x and the coefficients of y are either same or they are proportional. In this case, they are same. The only difference between their equations is they have different values of constants. For the first line, C1 is minus 9 and for the second line, C2 is minus 24. We will use the formula P equals mod C1 minus C2 upon square root A squared plus B squared. We have A equals 4 and B equals minus 3. Substituting the values, we write C1 minus 9 minus C2 minus 24 mod of this upon square root of A square, which is 4 square, plus B square, which is minus 3 squared. This gives us mod minus 9 plus 24 divided by 4 square is 16 minus 3 square is 9. 16 plus 9 is 25. So this will be square root 25. Now 24 minus 9 is 15 by square root of 25 is 5. So this gives us p equals 3. So therefore the distance between these two parallel lines is 3 units. Friends, if you like this video, please click the like button. Share this video with your friends and classmates. Do subscribe this channel to get more videos of this type. See you in the next video. Until then, keep watching Number Collage. Thank you.